Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 31. Today is the last day for January Daily Leetcode Challenge. And believe me, it's a very good question. And you will be very proud to see that though it is a hard question, and obviously it is one of those questions which is there in the first thousand of Leetcode. Okay, this is among the first thousand questions of Leetcode. It is hard. At the same time, you see the acceptance rate. Even now, like see, almost it's been like more than I guess say 15 plus hours since this question has come. Still, the acceptance rate is just 52%. Okay, which clearly shows why this is a hard question. Okay, it clearly shows why it's a hard question because acceptance rates even after 15 plus hours. Okay, normally what happens, acceptance will be less, but after like 15 plus hours of the question being released, this will increase. People will be solving this, they will be getting the answers, they will be solving it, right? But still it is 52%, which clearly shows why it is a very good question to solve. And today being the last day of January Daily Leetcode Challenge, I felt really happy and satisfied and proud when I solved this question. It was a very nice question, though the topics involved are very simple, but still you can say like it summarizes everything. Okay, remember, it also talks about graphs, it also talks about the traversals, dfs, bfs, all that. It also talks about the union find, which is also called disjoint set union topic. And the solution that I will be showing you is again based on the same topic, disjoint set union. Okay, I will be showing today another version of it. See, normally what happens, lead code, if you see, they have a particular template for this disjoint set union. They create a class and they write the solutions for it. Today I will be showing you like very simple way how to do it without creating all those classes and all. We'll just use the one which we required. We will separate the rest. Okay, we don't need the rest, we'll just use the one which we need. Okay, simple as that. And similarly, if you see the important part is, see this, the length is 500. So the idea here is, just with a brute force you will not be able to solve this. Okay, that is the main difference between yesterday's question and today's question. Yesterday also was hard question, but the thing is, with slightly optimal brute force you will be able to solve it. Okay, just with a simple bfs, with slightly optimized way, you are able to solve the question. But in today's one you will not be able to solve it just with brute force. Okay, I will tell you why. Okay, this question has so many possibilities. If this comes in interview, I will say that you are lucky. But again, it's all about how much practice that you have done in order to convert this luck into your selection in an interview. It's all about that, right? Now coming to this question, let's begin now. Just want to tell you that it's a very good question, please do not leave it. And I will say that if you have time, see, the weekend is coming. If you have time, if you have not done this, take some hours, sit and try and keep trying. Okay, at least spend 1 or 2 hours. I'm sure you will get it if you have been very consistent, very I will say true to yourself. Okay, if you have been true to yourself, if you have been true to the coding world, I'm sure that you will be able to solve this. You will be able to crack this question, right? Now coming to this question, it's 8 to 7, making a large island. Let's see what the question is. Let me zoom in and let us begin. So basically, what you are given is, you are given a grid. Okay, normally the same thing will be given in every graph question. So we are given a grid, and this is going to be a binary grid. What is a binary grid? Binary grid means that each element in this grid is either 0 or 1. Okay, each cell is either 0 or 1. So let's see. And one more thing, it is going to be square matrix. Okay, this is another thing that you can know. So when you are calculating the time and space complexities, you can just use a n, and you don't have to use m. Okay, normally what we do is we do m into n, right? The dimensions of a graph, two dimensions, m into n we do. But since it is going to be a square matrix, you have to write in terms of n. Okay, now you are given n cross n binary matrix grid. You are allowed to change at most 1 0 to b1. Okay, what it means, we'll come to this later, because this is all, the whole question revolves around this. Okay, so I will again come to this, but let us complete the question first. Return the size of the largest island in grid after applying this operation. Okay, after applying this operations. Okay, an island is a four directionally connected group of ones. So what they're saying, see, what is island? Basically, island is basically a group of ones. Okay, they should be connected in a four directional way. Okay, the examples are not very good here, but see, let us see the example number 3. If you see what is happening, the number of ones are connected, so all the elements are one, first of all. Okay, that is the point number 1. Second point is that if you try to connect them diagonally, okay, what you will get is, you will get a area of 4. Okay, a area of 4 is present, which belongs to island. Okay, which belongs to land, so it's island. So we can say the answer is 4. Okay, so what they're trying to tell you is that you are allowed to change at most 1 0 to 1. Okay, as simple as that. Return the size of the largest island grid after applying this operation. A island is a four direction connected group of ones. Okay, so what you have to do, you have to connect once, and there can be at least at max 1 0 that you can convert it to 1. Okay, so what you can think of is, for example, see this. Let us go to example number 1. See here, here 1 is there, here 0 is there. Okay, here again 0 is there, here again 1 is there. Now, any one of these zeros can be converted to a 1. Okay, remember, they are saying just at most. That means it's not compulsory. Okay, for example, in example number 3, you see, there is no way for you where you can convert. There is no 0 present, so you cannot convert anything. Okay, so that's why they have also mentioned that. So you have to just at max, you have to convert 1 0 to 1. Okay, now see this case. If I convert this 0 to 1, what will happen? I will get answer of 4 because there are 4 ones. So the total land area in this graph is the total connected land area, or I can say like the max island, the max land area, max connected land area in this grid is going to be 4 of length 4 of area 4. So it is going to be 4. Now in this, if you see, okay, let me draw this and show it to you because like I don't feel like feel comfortable while explaining it because it's not very intuitive to see them written like this. So see, this is the one, okay, 1 0 and then 0 and 1. Okay, now what will happen is, see, if I make this as 1, okay, let us do it. If I make this as 1, so what will happen? It will now be connected. These two and this one. Okay, now these three will be connected together. Okay, now in total their area is going to be 4. But let us say this is 0. In this case, if you see, if you are not able to convert, then the answer is going to remain 1. Okay, remember, you have to return the maximum connected area. So these two are not connected, by the way. Okay, this one and this one are not connected. For them to be connected, at least this one or this one have to be 1. Okay, and since we can convert at most 1 0 to 1, so what we'll do is we will convert one of them to 1, and yeah, then we are getting answer as 3. Okay, because this in total will become an area of 3. Okay, so the answer is going to 3. So this is all about this question, right? Let me just remove this part. Yep, so this was all the question. Now where the issue is coming, see, what you can do is you can solve this question using simple BFS. I know that, but the challenge here is the constraints are not that small. Okay, the constraints are up to 500, so it's going to be a 500 cross 500 matrix, which is not a small one. And believe me, just with simple BFS, if you're not using any optimizations, your solution will not be accepted. Okay, there are, I guess, around 72 test cases by test case 50 55 itself, but you will start facing the time limit exceeded error. Okay, so how to solve this? So we will use the union find approach. So what will we see? First of all, we will try to group all the ones which are connected. Okay, let us say like there could be multiple ones, right, which are not connected. They are like separate. So what we'll do is, for each group of one, so please like write down if you want, but please listen to the ideas, because remember, it's all about the ideas. Once you know the ideas, you should be able to code the solution. Okay, that is what is expected out of you. Okay, it's a hard question. You can imagine, like, when you're solving this question, just imagine that you are in a FAANG level interview and you are given this question and you are solving it. Okay, so please be that much consistent, please be that much sincere while doing this question. Okay, now how to use the union find in this? What is union find? Union find is basically the disjoint set union. So what we are going to do is all the connected ones. Okay, there could be multiple patches of ones. Okay, for example, if you see, okay, let me take this example itself, the example number 1 itself. So what will happen is, if you see here, example number 1. Oh, fine. It is 1 0 and then 0 and then 1. Okay. So if you see, this is one component, this is one component. They are not connected. Okay. So what we are going to do is, each one of them we are going to take them as a disjoint set. Okay. Now for each connected component, for example, this is that. Okay. Let me draw some more, because like this is not enough for me to explain the solution to you. Okay. Let me like extend it further. Okay. So that it becomes easier for me to tell you. Okay. Now it makes sense. Let me zoom in and let's begin. See this case. If you see, these three are connected. Okay, these three are connected. So what will happen is, this whole group will, first of all, will explore all the ones which are connected. So these three will be exploring. Okay, and then we will elect a leader for this. Okay, so one of them will be a leader for this, and that leader will tell me how many ones are there in this particular group. Okay, fine. Similarly, this single one will be a group in itself, so it will be the leader of its own group. Okay, similarly, now after all these things, we'll start exploring the zeros. So what we'll do, for zero, we will see for every zero what could happen. See, we will go for the 4 adjacent cells of this zero. Okay, that is this one, anything above that, anything below that. Okay, what we'll do, if we see a new group, that is, we'll try to see how many different leaders are present in the 4 additional cells of this zero. Okay, now for example, in this case, this is a new leader. Okay, this is a new group and a new leader. Similarly, for this one and this one, they are adjacent to the zero, but remember, they belong to the same group. For that reason, they will be taken into account only once, and the leader will tell them how many members are present in this particular group. So that will add, and then we will try to expand how many maximum area we can cover. Okay, that is going to be a solution. I will show you the same now. Okay. Yep. Let us begin now. So before that, see, first of all, I will explain you these some of the topics, and then I will show you the one of my answer, and then we'll, through that example, we'll try to trace the solution. Okay, what are that? First of all, we are capturing the length. Okay, it's going to be square matrix, so there is only one. You can say one value, because both the height and the width of the grid is going to be same. Now, the directions, as I mentioned, you have to go for a 4 directionally connected component. Okay, so in this case, the directions are going to be 4. Remember, we are not considering the uh, diagonal adjacent cells to be, if you see, for a connection, for a connected group, they are not considering diagonal adjacent as a part of it. Okay, you have to only consider the 4 directional connection as a part of it. Okay, as simple as that. Now if you see, these are the 4 directions. This is the direction which is taking you to the Right. This is the one which is sticking to the left. This is the one which is sticking to the bottom one. This is the one which is sticking to the top one. Okay. As simple as that. Now, this will be the final answer. We are starting this with 0. Now, these two things are most important ones. You can say, like, if you have seen my videos previously, if you know disjoint set algorithm, remember, by the way, this is also called union find. Okay. So do not confuse the two topics. They are same. Okay. These are also called union find. Now, see this case, these two things will be helping me in my union find algorithm. Okay, so in the disjoint set algorithm, how they work, I will tell you that. I see I'm not using the classic one, which normally LeetCode uses, because I don't feel the need to use it. This is again same efficient, similarly, and I will be using that. Okay, it's equally efficient. It's, I guess, say more efficient than that, and that's why I will be using it. Okay, because there are a lot of regression happens to find the leader and all that. I do not want to use that. I will be using the simple one. It's very simple one, and in this case, it fits the best. Okay, now how to do that? See, this is the empty list, and again, the dimension, if you see here, this is the dimension is same as that of the grid. Okay, that is, the number of elements in the grid is equal to same as the number of elements in this representative cell. Okay, what this will tell? This will tell me what is the leader for the current cell. Okay, for example, for each cell, this will tell me who is the leader of the group to which the current cell belongs. So if you have a pen and paper, please write it down. This will tell us what is the leader for the current group to which the current cell belongs. Okay, I will show with some examples. See this case. So yep, for the let us go to example number 2. Okay, that will be the good one. Now see here what happens. Here these three are connected. Okay, these are connected with each other. Okay, since they're connected with each other, what will happen? Now they will be part of a single group, and there will be only one leader for them. Okay, so if you see here the representative of that, so what happens? They are saying like this particular cell belongs to a group whose leader is 0. Okay, similarly this particular cell belongs to a group whose leader is 0. Okay, similarly this particular cell belongs to a group whose leader is 0. Okay, and if the leader is minus, so for this, if you see the leader is -1, that means there is no leader for this. Okay, -1 means there is no leader for this. Okay, so leader 0 means that what you have to do, you have to go to the 0th element of this particular list. Okay, so what is the 0th element of this particular list? This is the 0th element of this particular list. This will tell us what are all the elements other than the current node. So what are all the elements in the group, in the overall group, and what is the length. Okay, for example, if you see this particular number tells us that it belongs to a group whose leader is 0. So let us see how many other cells are there in this group. So these are the other cells in this group. Okay, I'm going to 0th element, and if you see, we can get the length also. Okay, as simple as that. Okay, that's what we are going to do. Okay, now let's begin the question. So I hope you have now cleared what are these things. Okay, you will get more clarity on it when you see the solution. So this is my BFS component. Remember, the whole question revolves around this BFS. So I will show you what happens. See, first of all, what we are going to do: start the BFS with nodes where value equal to 1. Okay, that is all the cells which are having a value 1. We'll start with them. Okay, what we are going to do? It's going to be a 2D. That is, we are going to have two loops to go through each of the cells. That is, for each column we are going through each row. Okay, I mean, like, for each row we are going through each column. Right now, if grid of I comma j equal to 1, what you have to start the BFS. Let us see what the BFS does. So what the BFS does is that it will explore all the nodes. Okay, that is, all the nodes connected to this particular node will be explored. Okay, all the nodes which are connected to this particular node. Remember, when I say BFS, I mean all the nodes which are 1. Okay, that's all the land nodes connected to the current node will be explored. Okay, and then their value will be changed. How that happens, I'll show you. But just understand that after node is explored, okay, see, currently its value is 1. After the node is explored, its value will become -1. Okay, just know that for now, so that the thing will become more clear to you. Okay, that's why, see, I have not explained this part currently, how the grid is coming like this, because of that only. Okay, once I explain that, I will come back to this. Okay, now see here, I start the BFS. So again, I will tell you the context, what is happening. If the grid value is 1, okay, if the grid value is 1, what I do, you have to start BFS. BFS will, try to see BFS, right? It's a breadth first search. What it will do is, it will explore all the nodes, that's the nodes which are land. Okay, which are 1. So let us see how it works. So yep, this is the BFS function, where, as you know, for BFS we need a queue. Okay, we always need a queue for BFS. Now, what we are doing in the queue, we are appending the current node. Okay, this is going to be the current node, right? So I'm appending this as a tuple. Okay, so what I have highlighted currently, that will be a single element in my queue. Okay, this is going to be, this is called a tuple in Python. Okay, this I'm appending it now. Since this is a fresh BFS traversal, what you have to do, you have to add a new value to this. Okay, so what we are doing, see, this one, I am adding a new value, or I am appending a new value. Okay, so what will happen, I am appending, okay, in this particular list, I am appending a new set. Okay, why a set? If you see, this is basically a set. What we're seeing here is a set. Okay, the set will store what are the elements in this particular component is having. Okay, this particular, I can say, component is having, this particular connector component is having. Then I will elect a leader for this. Okay, what is the leader? What is the value of the leader? The leader value is going to be the index in which this new set is added. That is the last index. Okay, since currently this is the last value in this. Okay, so the leader is going to be basically the index in which this new value is added. Okay, obviously it is going to be the last value. So how to get that? Length of this, okay, length of this minus 1. Okay, this will tell us what is the index of this particular value. Okay, what is the index of this set in the disconnected islands list. Okay, in the disconnected island list, what is the index of this particular newly added set? Okay, this is going to be our leader. Okay, since each index is specific, each index is unique, so this leader is going to be unique. Okay, throughout this leader is going to be unique. Okay, now we have elected the leader also. Now let's add the values inside this set. Okay, how to do that? See, I again mentioned, if you go to disconnected islands and if you go to this particular index, what you will get this newly added set. Okay, so please be very clear in this. Next, what we're going to do, the current edge that we have, this particular current edge that we're first of all going to add it to our newly added set. Okay, how to do that? See, I'm going to disconnected islands. Okay, this is the our list. In that, I'm going to this particular index. This index will take us to this newly added list. Okay, in that list, what I'm adding this tuple. Okay, this is my the node which I'm starting the BFS. Okay, as simple as that. Now the leader is already elected. So what we have to do for the current node, okay, for this particular node, I'm just marking the leader. Okay, so I'm going to representative I comma j, and I'm placing the value as leader. Okay, what is the value of the leader that will be shown here? Okay, so ultimately what this will tell me if so. Let me go to the again. Yeah, see, as you can see, this is value 0. What it means that for this particular cell, if you go to the same indexes in the representative array, this will tell us the index in which we need to go and see and find the other cells in the same connector component. Okay, as simple as that. Why that is useful, we'll come to that. Okay, we'll come to that. So what we are doing, for all the cells that are visiting in this BFS, for them the representative will be this particular leader. Okay, that's something that we have to remember. Okay, remember, this is the ideology of a union find algorithm. So if you're not understanding what I'm saying, you need to first of all learn what is union find, since we have covered union find in some of the previous questions also, like few days back. For that reason, I'm going a bit fast, but if you have any doubts, okay, what you can do is please pause, just do a Google search of what is union find, what is disjoint set union, or if you want, you can just go to last 7 days question and check that out. There are some very good questions that we have discussed previously, and since those are very good level questions that we have discussed, for that reason, I am assuming that you are now at least bit confident with this topic, so I can like progress without a doubt that you are not understanding. Okay, so that is my understanding. Please do let me know if you are not understanding. Maybe like I can ping in the comments, if you like ask any doubts, I can ping you those video links where you can again go and learn from scratch. Okay, these things that we have discussed previously. That's why I'm going a bit fast. Okay, now leader is selected. Okay, now go to that newly added set and add the current element. Okay, the current node that we are going to start with in the BFS. Now since the leader is already known, so the representative of this particular cell is going to be this leader. Okay, so by the way, all the nodes that we are going to visit, okay, all the cells that we are going to visit in this BFS will be marked with this leader. Okay, the representative of all of them is going to be this leader. Okay, as simple as that. Now since, so remember, again I will say, BFS will start when the grid value is 1. Okay, since the grid value we have already visited a cell, so how to mark that? Remember, we are not using any set as such. Okay, this is the only set we are having, we are not maintaining visited set. For that reason, what we are going to do is, this grid value will now be changed to -1. Okay, previously it was 1. Okay, now we made it to -1, because see, otherwise what will happen, no? If you don't make it -1, so again when the value comes there, that will again be excluded. Okay, we don't want that, we want it to be excluded only once. Okay, for that reason, we are changing its value to -1. The only idea behind that is that we do not want that condition to be become true here again. Okay, I don't want the BFS again to start with that node. Okay, as similar as that. Okay, for the reason the BFS, the grid value is made -1. Okay, now the queue will start till the single element is in the queue. This loop will continue. We are popping left. Remember, this is a DQ. DQ means a double-sided queue. So the append will happen from the right, the pop will happen from the left. Okay, so as you can see, pop is happening from the right, left, and the append. Okay, where it is append, where did it happen? Yeah, the append is happening from the right. Okay, now see, we are done the pop. I've got some value here. Now for all the adjacent cells of this particular node, I will go now. Okay, so I'm going to for a comma b in directions. Okay, as I mentioned, this is the constant one. Okay, these are directions. Okay, so what we'll do is we'll go through all the directions. Okay, for a comma b in directions, and we'll calculate the adjacent values, adjacent cells. Okay, so what we're doing, for the current x, add a. Okay, add a. For current y, add b. Okay, so x plus a, x, y plus b, so we are getting double x double y. This is going to be one of the adjacent cells. Okay, remember, it could be outside the grid. So for that, we are checking if double x not in the range n or double y not in the range n. Remember, it's our condition. So even if x or y is outside, double x or double y is outside the grid, still we should not proceed with that. Simply continue the next loop. Okay, as simple as that. Now if this particular tuple, okay, this particular tuple is already visited. Okay, how to know that? See, if it is present in this, okay, disconnected islands, and go to this particular index, if this will take you to this set. Okay, this will take you to this particular set. Okay, yeah, this particular set. So if this tuple is already visited, what you have to do, you should not be continuing. Okay, simple as that. Or if the grid value is not one, that means this cell is not visited, but this cell is not a land cell. If it is not a land cell, and if it is not a visited cell, we have we don't have any interest in that. Okay, so see this condition: if this cell is already visited, or if the cell is not a land cell, in that case, continue. We are not interested in this node. Okay, if this is also not true, then we are interested. What will, so when this code will executed, this code will sorry, this code will executed when the current node is not visited. At the same time, the current node is a land node. Okay, so what we have to do, first of all, we will add that, okay, to our this particular, okay, we'll add it to this, okay, this connected island leader. Okay, we'll add it here. We'll go to disconnected islands, we'll go to this particular index. In that, we'll add this. So where it will be taking you, this will be taking you to this set. Okay, as simple as that. So we will add this tuple there. Okay, and then since it is now visited, what we'll do, we'll mark its leader. Okay, the leader for this cell, okay, double x double y is going to be this particular leader. Just a second. Yeah, this particular, remember, the leader remains the same throughout this BFS. Okay, throughout this BFS, the leader remains the same. So whatever nodes are visited in this BFS, for them the leader is going to be this. Okay, as simple as that. Next, we are appending this to the queue. Okay, this particular tuple will append it to the queue. And now since this is again visited, okay, so it's again already there in the queue. What we'll do, we will mark its value to -1. Okay, so these are the four things that we are doing. If you see here, also we have done, and here also we have done these four things. Okay, this one, and yeah, these three. Okay, as simple as that. And this is the leader election. This will be done only once. Okay, so other than that, if you see this part, this one, and these three, so these three, these for there here also. Okay, the same for we are doing here. Okay, now this loop will keep continuing. Okay, and then finally, once we come out of this while loop, okay, that means we have wasted all the connected land cells which are adjacent or connected in the four directional way to the current node. Okay, now after that, what we are going to do, largest island area is equal to largest island area, that is the previous value of the largest island area. Remember, this and this are same. Okay, comma, the length of this. Okay, length of this set. Okay, this particular set I'm talking about. Okay, that is all the cells that we have visited in this iteration. Okay, in this BFS will be given by this. Okay, length of this. So what is giving you, this is giving you length of disconnected islands, and you have to go to this index. So this will is making, basically taking you to this set. Okay, if I can show you, see, this is the one. So this is a set. You will get the length of this. Okay, so this will tell you in total like how many cells we have visited in this whole BFS function. Okay, as simple as that. So we are just capturing that. Remember, till now we have not made use of this part. Okay, till now we have not made use of this part. That is, we are allowed to convert at most 0 to 1. We have not done that. Till now we are dealing only with ones. Okay, as simple as that. Now, as you know, since once we visit a node which is a land, we'll change its value to -1. Okay, so now in the grid, what are the values will be present? 0 will be present, 1s will be present, and -1s will be present. Okay, now this will keep continuing. So now you will understand why why this is needed, because see, all the connected components which is part of this, okay, which are connected to this in the BFS way, that will be now changed. So idea here is, this will be, BFS will be called for only one node for each connected component. Okay, that is the basic idea. So in this way, we are basically doing the optimization. Okay, remember, had I not done this, what will happen? The BFS will be called for each node in each of the connected components, which would have been a unnecessarily calculation, so unnecessary traversals, which you don't want. Okay, that's why we have done this. Okay, this is was needed in order, this is acting as terminating condition. Remember that when this is done, this particular condition will not be, becoming true for that again. Okay, as simple as that. So once once we are done with this, we have explored all the connected components whose value is 1. Okay, now we'll come to this part. Okay, now we'll come to this part. Okay, yeah, you are allowed to change at most 10 to 1. Okay, one, at most 10 to be 1. Okay, now we'll come to that. Now, before that, let us say a case is there. For example, we had this example number 3. Okay, where all are blinds. Okay, there is no, zeros. In that case, what can we do? We can simply get an answer. Okay, so if the largest island area is equal to 0 to n into n, okay, that is, all the cells are basically land. In that case, there is no 0 present. Okay, there is no possibility of this statement. Okay, there is no possibility of this. That means we are already done with our answer. We will return this as the answer. So answer is going to be n into n. Okay, that we saw in this case. In this case, the answer is n into n. Okay, so if you see, 2 into 2 is 4 is the answer. Okay, as simple as that. So that will return. Okay, if no node exists with value equal to 0, then return calculate answer. So whatever the answer, you have written that. Okay, now comes the most tricky part. Even if a single node exists with value equal to 0, then try to maximize the existing answer. Okay, so this is the most important part. See, our aim is to, for example, I will show you this. Okay, see this case. Let me show one case like this. Okay, well, let us say this is our graph. Okay, let us say this is our graph. Now, as you can see, like by the end of this, okay, by the time we are here, okay, let me zoom out again. Okay, by the time we are here, what would have happened? See this case. By the time we are here, what would have happened? See, we would have already explored this, and for this whole group there will be a single leader now. Okay, that leader will tell us how many cells are there in that group. Okay, and there will be a single leader. So the representative of all of these will be one. Okay, and similarly this will be acting as a separate group. So the representative of all of these three will be a separate value. Okay, for this will there will different representative, for this there will be different representative. Okay, this is like a disjoint set. Again, this is like a disjoint set. Okay, as simple as that. Now what we have to do, see this zero or any of the zeros here, by the way, any of the zeros, what will happen? Even if I make this as one, okay, let's say if I make this as one, what will happen? Now I will be able to bridge this. Okay, this and this will now be made one. Okay, so this whole different separate component, disjoint set, and this disjoint set will now be made. Now we'll be doing union of them. Okay, that is the why the idea is coming. Disjoint set union will now be done. Okay, this set and this set now will be getting union. Okay, because of this. Okay, this will act as a bridge of that. Okay, that is going to be our basic idea, right? So see what we are going to do. Please pay attention, because see, this is going to be the most important part and tricky part. See, I will again go see again, like two follow-ups will be there. Again going through all the notes. If a grid value is zero, okay, if a grid value is zero, there is a possibility that it might be acting as a bridge between two connected groups of ones. Okay, we'll try to see that. So what we'll do, see, we are creating a set called leaders in. This will tell me what are the leaders that we are seeing for the four adjacent cells. Okay, we will just go to the four adjacent cells of this. Okay, see here, I will again say this is zero, right? Now for this, what are the four adjacent cells? Okay, this is the one, this is the one, and this is the one. Okay, the other left one, there is nothing. Okay, we cannot go that. Okay, now for this is the one, right? So let me write the leaders in. This is going to be a set. Okay, so let me write it like this. Okay, now so for this, what is the leader scene? For this, the leader scene, let us say it is one. Okay, now what is the leader scene for this? Now since this value itself is not one, so there is no leader for this. Okay, leader will exist only for the nodes which are having a value of one. Okay, so there is no leader scene for this, but here for this, again there is a separate leader scene. So these are the two leaders with that will scene. Okay, now this leader will tell me how many nodes are present in this whole thing. Okay, so this whole thing will get the values of this whole connected component through this leader. Okay, similarly we'll get the number of ones here through this leader. Okay, so that is the idea going to be. Okay, that's what we are going to do now. Okay, now see here. Yep. So if the grid value is zero, what we are doing, we are creating a leader scene set. Okay, we are creating a basic area covered. The area is starting with one. Why? Because remember, this value also is going to be turned to one. Okay, since this will be turned to one, so this will be acting as the area of unit one. Okay, now for a comma b in directions, again same thing, like I'm going to all the adjacent cells of the current node. Okay, for the current node, okay, I comma j, I'm going to all the adjacent nodes. Okay, again same thing, if double x is not in range or double y is not in range, that is if any of this double x or double y, if they're not in a grid, what we have to do, simply continue, because that we cannot do anything. Okay, we cannot do anything now. Other than that, if the grid of double x double y is equal to minus 1, okay, why minus 1? See, as I mentioned, all the ones that are present would have been minus 1 by this. Okay, so by the time this particular code is done, what will happen? All the ones that are present will now be as minus 1. Okay, will now be present as a minus 1. So we are checking whether the adjacent cells for the current node. Okay, what is the current node? Current node is I comma j. So any adjacent cells, okay, all the four adjacent cells we are going through now, each one of them, okay, at a time. So if the adjacent cell, this particular adjacent cell, if the value is minus 1, that means it would have been a 1 previously. Okay, so it could be connected, that is, this could be a starting point of a big connected component. Okay, right? So what we'll do, we'll try to capture its representative. Okay, so if the representative of double x double y, okay, this will be actually pointing to its leader. Okay, this value will be pointing to its leader, remember that. If it is not in leader scene, okay, if we are seeing this for the first time, okay, if the leader that is it is telling about, we are seeing for the first time, in that case what we have to do, we'll have to first of all leader scene dot add this particular value. Okay, what is this value? This will tell me the leaders. Okay, what is the leader for this particular cell? Okay, if I can show you this, I can see here all these values. See, these three values are one, right? So for all of them the leader is going to be zero. Okay, so what is this zero? Zero will tell me that, that means zero in this particular list, go to the zeroth index. Zeroth index, here it is. Okay, so zeroth index means you will get to know what are all other I can say cells which are present in this particular connected component. Okay, that is what we are trying to get. Okay, now we are now getting the leader. Okay, we now have the leader. What we'll go do, see, we will just take the length of this. Okay, so what I will go, I'll go to disconnected this one, and then I will go to this particular index. Okay, this particular index will be that of the leader. Okay, that is the leader itself, and then I will take the length of it. So this length will tell me how many more ones are present from here. Okay, from here on. So that I will add to the area. Okay, as simple as that. Remember, each leader will be vested only once. That's why we are using the set. That is, if the leader is already vested, you should not do that again. We should not count it again. Okay, you should not do this addition again. Okay, as simple as that. So once you have done this addition, what we have to do, See, this for loop will continue like that. Okay, these things will continue like that. Finally, at the end, what we'll do is we'll just check if the largest land area, just like this we did here, right? Just like we did here, same thing we are going to do here also. Just like we did here. Okay, so largest land area is equal to max of the previous largest value, comma this particular area. Okay, this particular area. Here it is starting with 1, then we're adding all the connected components 1 that we are getting to here, and then we are seeing it. Okay, yep. Finally, we are returning this as the answer, and this print statements are just for your help purpose. So when you segment the solution, please do comment out these things. Okay. Now I will explain you all the three solutions with this. See here, all are ones here. Okay. These all ones will be made -1 in the final grid. Okay. This is all known. Then all of them will have a single leader because they are connected to each other. Okay. And these values are going to be 0. This see, only ones will have a leader. Okay. All the ones that you're seeing here, only that will they will have a leader. Zeros will not have a leader. Okay. Just remember that this will remain -1 always. Okay. Now, so when you see how to interpret this is 0 means I will have to go to the 0th index of this particular list. So 0th index of this particular list is this set. This set will tell me what are the other what are the other cells which are part of this connected component. Okay, this was example number 2. Let's go to example number 1. Okay, now see here this is the one. Okay, here this is the one. These two are not connected, so for each of them there is going to be different leader. So see here, for this particular one the leader is going to be 0. Okay, similarly for this particular one the leader is going to be 1. Okay, as simple as that. Right now, so this, if you go to 0th index of this, you will get to know that what are all the cells which are part of this particular connected component. There's only one cell, so only one value is there. Okay, similarly if you go to 1, okay, that is you go to this cell, go to this list, go to index number 1, this the index number 1. This will tell you what are all the cells which are part of this content component, since only one value is present. So only one coordinate is present. Okay, 1 comma 1. Right now, yep, the same thing we'll do now. For wherever you will see 0 here, what we're doing, we are going there and we are just trying to get we're just trying to do again start a bfs, but this time we'll not do the whole bfs. What we'll do, we'll just go through the 4 additional cells of the current cell. Okay, for example, if we start with this, what we are doing, we are going through this. Okay, we are going through this, and yeah, that is all. Right, only these two we are going. Okay, now for each of them we are just taking the length from the connected components. That's the total number of components, and we're adding it here. Okay, finally we're getting the answer as 3. Right now, the last one, in this case it's the exceptional case. Okay, so here actually what will happen is, here itself will return the answer. Okay, here in this stage itself will return the answer. So this will saving us a lot of complexity, because this avoids this whole double loops. For that reason it will save some of the time. Okay, so often that was all for this question. This was a very interesting question. If you're not understood till now, I will say one thing: please don't worry. Even it took some time for me, but what I can do is, first, my advice to you will, if you have not understood anything till now, what I will say is, don't worry. It's your confidence that you have made here till now in this video, because see, if you have not known anything, if you have no interest to learn also, you would have skipped this video by now. Okay, so if you have been watching this video till this point, I know that you want to know something. Okay, see what you have to do, search about this topic, this site union. Okay, you can also see LeetCode calls this as union find algorithm. Okay, you can also search that. Okay, there are LeetCode cards for this. Go through that, understand what is happening. So what you will get to know is that there are separate sets. Okay, these are disjoint sets. Okay, there are disjoint sets. For each of those sets we have to elect a leader. Okay, so how to do that? For that we are creating this array. Okay, as simple as that. Now, in order to know how many, see, first of all, let us say I have a leader, but I should know, right, this leader belongs to a group, but in that group how many values are present. For that I am creating this. Okay, this is the reason for that. Okay, now when you know these two, what we'll do is, for each of the ones, okay, each of the connected ones, we are going to create a group, and that group will have a leader. Okay, so all, if you go to any cell, the representative of that will tell me, okay, which is the leader to the group which the current cell belongs to. Okay, and when we know the leader, we can come to this and we can go to that particular index, and that will tell us what are all the other cells which are present in that particular group. Okay, along with the current cell. Okay, that is the basic idea. This is a very simple solution. It's all about ideas. It's all about exploring what happens. Remember, like, just to tell you, this is my third or fourth solution. Previously I've tried multiple solutions, but what happens, if you are not optimizing, what to extent, after the test case 50, I can say you will start getting time limit exceeded error. Okay, so for that reason I have to optimize it to till this extent. Okay, initially I tried without these things. Okay, but it did not work out. Okay, so the idea here is, you should be calculating everything only once. Okay, all the ones should be calculated only once, all the zeros should be excluded only once. Okay, that is the only thing that you can afford with this much complexity. Okay? If you see, it is going to be 500 into 500, right? So you cannot be doing multiple iterations. Okay, multiple steps like that. Okay, so if you see, and you know that is 1 is explored only once, and you know that is 0 is explored only once. Okay, so you are seeing two whole for loops, that is double loops and double loops two times. Still, if you see, this is only for ones and this is only for zeros. Okay, for in that way, we're ensuring that we are going through each cell only once. Okay, as simple as that. Now, if you talk about space and time complexity of it, let us go through it. Obviously, since there are two for loops, okay, so it's going to, time complexity is going to O of m into n. Okay, that is point number one. Okay, I mean n square, because there are n into n solution. It's n square solution. Other than that, if you talk about the space complexity, see this part, these are the ones. Okay, so again, this, so for each set basically it will store the cells, the coordinates. So again, this is going to be okay, O of n square, because there are the total going to n square nodes, right? And similarly, this is again O of n square, because here its dimension same as that of the grid. Okay, so the overall solution is going to be n into n space complexity, n into n time complexity, right? This was all for today, and you can go through this. Okay, maybe like take some test cases, print these things and try to see what happens. But remember, before you are submitting, just comment out this. Okay, you have to comment out like this and then submit, otherwise you will get output limit exceeded error. Okay, so yeah, that was all for this video. This was a very nice question. This is very very close to my heart, because I really enjoyed solving this question, and this being the last question, so obviously you should pay some price, right? If you have to get this batch, okay, January daily code challenge batch, you should be, having some, okay, gut feeling that yeah, I should be able to do it. This is the final step. That should be slightly hard, but still you should be able to achieve it. Okay, that is, see, if it is not hard, it's not worth achieving, right? So you should be working hard, and then if you achieve it, then you will feel that taste. Okay, so yeah, and that was all for this video. I really enjoyed the solution. I tried my best to explain the solution. See what happens, if you are not consistent, what happens, you're not solving this question consistently. So see, because in the last 2 days we have discussed a lot about union find, so I am thinking that you know those things, that's why I'm going a bit fast. But sometimes what happens, you have not solved those questions, but directly coming to this hard level question, that is not at all advisable. Remember, this is a hard problem. Even the acceptance rate, if you see, it's very very low. Okay, so I don't expect you to jump to this question directly if you are not sure what is union find, or like how to do BFS and DFS and graph and all that. Okay, so then do not come to this question. Yesterday's question is also a hard one, but what I will say is, like last 7 days, we had some very good questions on graphs. Go through them and then come back to this question. Okay, I have uploaded all the videos for all of them. Please go and see them and then come back. See, often that was all for this video. If you like my efforts, if you like the quality of my content, if you want to ask me anything, or if you have any doubts, if you want to be in a community, if you want to feel like a part of the community, please do comment out. Please do subscribe to the channel. This really gives a lot of spirit to continue further. You can also interact with other followers, other supporters. Just comment out whatever doubt you have. Me or someone else from our group will definitely answer you. Okay, so there are so many subscribers. We have reached around 1.5k subscribers, so definitely they're all like-minded people. Please do reach out. There are so many people, they will definitely help you. Okay, so yeah, that was all for today's video. So I've completed my 100 days. That was, yeah, a difficult thing for me, but yeah, I have done it. I'm feeling very confident and very proud of it. See you tomorrow. Thanks a lot.